In this video, we'll take a look at sections 3.1 and 3.2. Section 3.1 is complex numbers, and then section 3.2 is quadratics. So we do section 3.1 first and talk about complex numbers because we run into complex numbers when we solve quadratics. So what is a complex number? A complex number is a number in the form a plus bi, where a is the real part of the complex number and b times I is the imaginary part. So a number such as 2 plus 3i, 2 is the real part, 3i is the imaginary part. So what is an imaginary number? What is that imaginary number I? So what I actually equals is the square root of -1. So in previous classes, when you've had to square root both sides and you have answers like the square root of -16 or the square root of -45, your answer would be no real answer. So we're introducing the number system that allows us to have answers now. They're called imaginary numbers or complex numbers with imaginary parts. So if I is equal to the square root of -1, another commonly used expression is I squared. If we square both sides, I squared is equal to the square root of -1 squared. Whenever you square each side, we end up with I squared is equal to -1. So these are two common substitutions, I equaling the square root of -1 and I squared equal to -1. So some examples. Now we can take the square root of negative numbers. So if we take the square root of -16, remember to simplify. We rewrite that as -1 times +16. That means the square root of -1 times the square root of 16. The square root of 16 is 4, and now we just learned that I is equal to the square root of -1. So the square root of -16 now has an answer. It's 4i. It's a complex number. So now if we want to take the square root of -45, okay, we know that we're going to have square root of -1. Then we simplify the square root. 45 is not a perfect square, but 9 is a factor. So that's -1 times 9 times 5. That's the square root of -1 times the square root of 9 times the square root of 5. Square root of 9 is 3. Square root of -1 is I. So that gives us 3i times the square root of 5. All right, so these will come up when you're solving quadratics with quadratic formula. All right, arithmetic operations. We can add and subtract complex numbers. Treat these like you would with any variable. Add together the a plus bi, c plus di. We add together the real parts, a plus c, and then add together the complex parts, the bi plus di. We're adding the b plus d. So it's just think of it as adding like terms. So our examples, we're going to add 3 plus minus 4i and 2 plus 5i. Add the real parts. 3 plus 2, we're going to equal 5 plus, and then add the complex parts. -4i plus 5i is a positive 1i. So we get 5 plus I. Subtracting, we subtract 2 plus 5i from 3 minus 4i. So that means we write 3 minus 4i first, and then we're going to subtract 2 plus 5i. Distribute the negative. We get 3 minus 4i plus, basically turn it into an addition problem. Distribute the negative, -2 minus 5i, and then think of it as adding like terms. Add the real part. +3, -2 is a +1. Add the complex part. -4i plus -5i, or the imaginary part, is -9i. We can also multiply complex numbers. This is much like multiplying a binomial. If we find the product 4 times 2 plus 5i, distribute the 4. 4 times 2 is 8. 4 times 5i is plus 20i. Then if you've got a binomial times a binomial, think about it as FOIL, first, outer, inner, last. We're going to take, or think of it as just distributive property. We're going to take 4 times 2 minus 5i plus 3i times 2 minus 5i. Distribute the 4, we get 8. 4 times negative 5 is negative 20i. 3i times 2, 3 times 2 is 6i. 3 times negative 5 is negative 15. I times I is I squared. So this is the place where we're going to substitute negative 1 for I squared. So this is going to be a negative 15 times negative 1. So now when we add our like terms, we get 8 plus 15. So let me write it out. I have 8. Negative 20i plus 6i would be a negative 14i. And then this is going to become plus 15. And now I can add together the 8 and the 15 and end up with 23 minus 14i. All right, last idea for complex numbers is something called a complex conjugate. And a complex conjugate of a number, a plus bi, is a minus bi. It's found by changing the sign of the imaginary part of the complex number. The real part of the number is left unchanged. Okay, so find the complex conjugate of each number. If we have 2 plus I square root of 5, we're going to make the complex or imaginary part the opposite sign, 2 minus I times the square root of 5. If negative 1/2 I, then the conjugate is the positive 1/2 I. Important thing about the conjugates is when we multiply them together, what happens is we'll end up with a real number. So if we multiply a number times its conjugate, so I'm going to take 3 times 3 minus 2i plus 2i times 3 minus 2i. Distribute, I get 9 minus 6i. Distribute here, I get plus 6i minus 4i squared. Notice the 6i and negative 6i will cancel each other out. And I'm going to take that 9 minus 4 and substitute negative 1 for I squared. So I end up with 9 plus 4, which is 13. So when you multiply a complex number times its conjugate, the imaginary part will end up canceling out and you end up with a real number.